So far we have discussed the simple harmonic oscillator. Now we are going to discuss the time evolution of oscillator state gates and the observables like x and p, that is the position and momentum operator. The operators xp, a dagger are valid at some instant of time. So this can be regarded as Schrodinger picture operators. So in Schrodinger picture, operators are not changing at all. As well as in Heisenberg picture operators at time t equal to 0 were observable changes. So in this section, we are discussing the time development of oscillator in Heisenberg picture. So we work in Heisenberg picture. And the equation of motion is given by dA by dt is equal to 1 by IH cut A comma H, where the operator A is in Heisenberg picture. So it is to be understood that the operators are Heisenberg picture operators. We are not explicitly writing as xh of t. In the Heisenberg picture, equation of motion for momentum p and position x are, it is dp by dt is equal to minus tau by dou x of v of x. So the potential energy of simple harmonic oscillator is m omega square x square by 2. So we get dp by dt is equal to minus m omega square x. Put it as equation number 62, and dx by dt is equal to p by m, and it is put it as equation number 63. So this equation number 62 and 63 are actually a pair of coupled differential equation. So this can be written, or it is equivalent to two uncoupled differential equations for A and A dagger. So we have A. A is the annihilation operator, is given by this equation, root of m omega by 2h cut into x plus ip by m omega. So from this we can write dA by dt is equal to root of m omega by 2h cut is taken outside, and dx by dt plus I by m omega dp by dt, that is equal to root of m omega by 2h cut. It is p by m from the previous equation, where dx by dt is equal to p by m and plus I by m omega into, and dp by dt is equal to, we already said it is minus m omega square x, and put the value and just cancel the repeating terms in numerator and denominator. So we will get dA by dt is equal to root of m omega by 2h cut p by m minus I omega x, that is taking minus I omega outside, it is dA by dt is equal to minus I omega root of m omega by 2h cut x plus ip by m omega. So we can write dA by dt is equal to minus I omega a, because this is, it is a, isn't it? This is a. So dA by dt is equal to minus I omega a, that is the rate of change of annihilation operator. And the creator operator is given by A dagger is equal to root of m omega by 2h cut x minus ip by m omega, and dA dagger by dt is equal to root of m omega by 2h cut into p by m plus I by m omega into m omega square x, cancel m and m, omega and omega, we will get I omega into root of m omega by 2h cut into x minus ip by m omega. That is dA dagger by dt is equal to I omega A dagger, because this term is A dagger, which is the creation operator. Creation operator erases the state. So the solution of equation 64, that is, we want to find what is A, or the solution of this differential equation is, we want to integrate it, isn't it? So that is integral dA by A is equal to minus I omega integral dt. So this is equal to log A is equal to minus I omega t plus C, and A of t. So A of t is equal to e raised to minus I omega t into e raised to C. And we want to find what is this e raised to C. For that, we are applying the initial condition, that is at a time t equal to 0. Then what this will becomes A of 0 equal to e raised to 0 into e raised to C. That is e raised to C equal to A of 0 we got. So substitute in equation number 66. So we get A of t is equal to A of 0 into e raised to minus I omega t. And similarly for equation number 65, this also A dagger is equal to, that is A dagger of t is equal to A dagger of 0 e raised to I omega t. Just write these steps. So we get equation number 67 and 69. So from this we can set that the creation operator and annihilation operator, it exponentially, here it is exponentially decreases with the time, here it is exponentially increases with the time. So they are time dependent. Now we got we have the number operator. We want to find out what happened to the number operator with the time. So it is n is equal to A dagger A. So using equation number 67 and 69, we can write n is equal to A dagger of 0 e raised to I omega t, A of 0 e raised to minus I omega t. So that is equal to, this will become 1, isn't it? So it is A dagger of 0, A of 0. That is n is equal to actually A dagger A. That means the number operator is independent of time in Heisenberg picture. So where usually operators vary with the time, but number operator is independent of time in Heisenberg picture. But the creation and annihilation operator, it depend on time, exponentially dependent with the time. Now we want to find out the what happens to Hamiltonian with the time. So we have this equation for Hamiltonian, h is equal to n plus half h cut omega, where n is the number operator. We also said that number operator is independent of time in Heisenberg picture. Okay, so n is independent of time, then h operator, that is the Hamiltonian operator, also independent of time. So in terms of the x and p, that is the position operator and momentum operator, A is equal to root of m omega by 2h cut x plus ip by m omega. Then A of t is equal to root of m omega by 2h cut x of t plus I by m omega p of t. Put it as equation number 72. Then at t is equal to 0, what happened? A of 0 equal to root of m omega by 2h cut x of 0 plus I by m omega p of 0. So substitute 72 and 73 in 67. So we get the annihilation operator become A of t equal to root of m omega by 2h cut x of 0 plus I by m omega p of 0 into e raised to minus I omega t, root of m omega by 2h cut x of t plus I by m omega p of t, that is equal to root of m omega by 2h cut into x of 0 into e raised to minus I omega t plus I by m omega into p of 0 into e raised to minus I omega t. So here on both the side these are cancelled. So we will get x of t plus I p of t by m omega equal to x of 0 into e raised to minus I omega t plus I p of 0 by m omega into e raised to minus I omega t. Put it as equation number 74. Here we can use this relation e raised to minus I theta equal to cos theta minus I sin theta. Then what happens? This x of t plus I p of t by m omega is equal to x of 0 cos omega t minus I x of 0 sin omega t plus I by m omega p of 0 cos omega t minus p square by m omega p of 0 sin omega t. Put it as equation number 75. So in equation 75, it contains Hermitian terms on both the sides, that is the real part. Also non-Hermitian terms on both the sides, that is the imaginary part. So equating both the sides separately, we can write x of t equal to x of 0 into cos omega t plus p of 0 by m omega sin omega t. Put it as 76, and equating anti-Hermitian parts, we get p of t equal to minus m omega x of 0 sin omega t plus p of 0 cos omega t. Okay. So from the creation operator for a dagger equal to root of m omega by 2h cut into x minus ip by m omega. The following the similar steps from 72 to 77. I am not writing again. If you want, you can work out. I can obtain the same result. If you want, so we will get x of t minus I p of t by m omega equal to x of 0 and e raised to I omega t minus I into p of 0 by m omega e raised to I omega t. So from this we can reduce the same result. Okay. You can find out from A or A dagger. Okay. The same result 76 and 77. So I am leaving that an exercise. So here these two equations, look at this x of t and p of t. They are oscillate like they are classical analogues. That is like f of t equal to a sin omega t plus b cos omega t, which is a periodic function in classical. Here it is also similar. So this x of t and p of t are analogous to their classical oscillator. So from these two equations, that is x of t and p of t, we may conclude that what the expectation value of x and expectation value of p always oscillate with the angular frequency omega, but this is not actually correct. Okay, so take any energy eigenstate characterized by a definitive value of n. So the expectation value x of t is Brian, x of t kitten. So it is Brian. Put the value of x of t, it is x of 0 cos omega t plus p of 0 by m omega sin omega t ket n. Here a kitten is here. Okay, here is a kitten. So x of t is equal to Brian x of 0 cos omega t kitten plus Brian p of 0 by m omega sin omega t kitten. We are taking cos omega t outside. We get a Brian x of 0 kitten plus sin omega t by m omega Brian p of 0 kitten. Put it as equation number 79. Now we want to find out this. What is this? Isn't it? What is the expression value of x of 0 and p of 0? So for that, we have n x of 0, n is equal to 0, and n pn is equal to 0. So the steps is given here. You can just remember this result. So how will you get this as 0? It is given in these steps. Okay, it is not necessary to study. I am giving this for just for an outlook, how you work out with this bra and ket. So bra in x of 0 n is actually put the value of x of 0, which is root of m omega by 2h cut, and bra in a plus a dagger keten, that is equal to root of m omega by 2h cut bra in a keten plus bra in a dagger keten. So we want to find out what is this, isn't it? So that is bra in a keten is, it is bra in root 10 n minus 1, that is a is acting on keten, so we get a root 10 n minus 1, so that is equal to root 10 bra in keten minus 1. So this bra in keten minus 1 is actually 0. So we got the first value 0, and bra in a dagger keten is bra in root 10 plus 1 keten plus 1, and root 10 plus 1 is taken outside because it is an eigenvalue, and the remaining is bra in keten plus 1. So this is actually 0. So we get expression value x of 0 is 0 and b of 0. Similarly, b of 0 is 0. That is why it is, I am writing this as 0. So equation 79 becomes expression value of x of t is equal to 0. Similarly, expression value of p of t is also equal to 0. So from this we can say that the expression values are independent of time. So the n is independent of time, number operator. Also the expression value of position and momentum operators are also independent of time. So these conclusions agree with our earlier conclusion that expression value of an observable taken with respect to a stationary state does not vary with the time. Okay. So classically expression value of position and a momentum operator changes, but quantum mechanically we showed that the expression values does not change with the time. So in order to make the oscillations reminiscent of the classical oscillator, we must take the superposition of energy eigenstate. Okay, so to observe oscillations reminiscent of the classical oscillator, we must take a superposition of energy eigenstate such that ket alpha is equal to, we are taking this superposition of energy eigenstate. It is defined as ket alpha equal to C0 ket 0 plus C1 ket 1. Put it as equation 82. So expectation value of the position with respect to ket alpha, we can write it as bra alpha x of t ket alpha is equal to, it will become bra 0 C0 star plus bra 1 C1 star x of t into C0 ket 0 plus C1 ket 1. So this is the steps, the step by step valuation. Again, you don't want to study this. I'm just work out now. We already taken ket alpha equal to C0 ket 0 plus C1 ket 1, and we are evaluating the expression value of x of t with respect to this alpha. So that is, I am writing it as C0 star bra 0 plus C1 star bra 1 x of t C0 ket 0 plus C1 ket 1. Now what we are applying the x of t, the value of x of t in the next step. Okay, so it is the value of x of t is actually x of 0 cos omega t plus p of 0 by m omega sin omega t. Anyway, now we are going to expand this. So we will get a mod C0 square bra 0 x of t ket 0 plus C0 star C1 bra 0 x of t ket 1 plus C1 star C0 bra 1 x of t ket 0 plus C1 star C1 bra1 x of t get 1. Here this 0x0, this 1x0, and these are become, it will become 0 because we have this relation. Because look at here, only we knew this equation, that is bra n prime x get n, that is the matrix element. We already represented these operators in terms of matrix element. So the matrix element is given by, it is bra n prime x get n is equal to root h cut by 2 m omega root n delta n prime comma n minus 1 plus root n plus 1 delta n prime get delta n prime n plus 1. So look at this Kronecker delta. When n prime equal to n plus 1, then only the element exists, matrix element. So when n prime and n plus 1 are equal, that is the same elements, that is if it is a 1 1, then that element does not exist. Only if n prime equal to n plus 1, this delta will become valid, isn't it? So other terms are cancelled. So you can directly found from this matrix representation. For similarly for the P, matrix element of P is bra n prime, Pn is I into root of m omega h cut by 2 minus root n delta n prime comma n minus 1. So n prime equal to n minus 1, then only the matrix element exists. Also n prime equal to n plus 1. Okay, so here, or we can just do the steps here. Here I am working out this step, the first step, how it will become 0. It is mod c0 square. I am just rewriting that term only. Mod c0 square bra 0 x of 0 get 0 cos omega t. So putting the value of x of 0, that is mod c0 square root of h cut by 2 m omega bra 0 a plus a dagger get 0 cos omega t. So it is bra 0 a get 0 plus 0 a plus, sorry, a dagger get 0 cos omega t. So what happened, there is this constant is here, it is here actually. So what happened to the terms in the bracket, it is when a act on, it is the annihilation operator. So the get 0 become 0 minus 1, that will become get minus 1, isn't it? So root 0 get minus 1, and here also root 0 plus 1. So this term becomes 0 because it is root 0 into some get, and here also root 0 plus 1, that is root 1 into bra 0 get 1, this is 0. So the total value is 0, that is we can write bra n x get n equal to 0, bra n p get n is equal to 0. Only the terms with the delta n prime comma n plus 1 equal to 1 exist, that is n prime should be equal to n plus 1. Here also n prime should be equal to n minus 1 and n prime equal to n plus 1. Okay, so that terms are cancelled and remaining terms are mod c0 square this bra 0 x of 0 cos omega t plus p of 0 by m omega sin omega t get to 0 plus the next term is there, and the next term is also given here. Okay, I'm not explaining it, you can work out. And now what, and again I'm rewriting this equations as now I'm applying this equation, it is n prime x n, isn't it? And here also it is n prime pn. Okay, so I'm just applying these values. We will get is root 1 delta 0 comma 1 minus 1, then this will become exist, isn't it? that will exist. So finally we can write it as finally we get the expectation value as cos omega of t plus something plus I sin omega of t plus something. So that is, it is like a sin omega t plus b cos omega t in classical mechanics oscillating with the frequency omega. So only we get the classical reminiscent if we choose ket alpha equal to what? C0 ket 0 plus C1 ket 1. So we get that expression value of position operator at a time t oscillating with frequency omega. So bra alpha x of t ket alpha equal to a sin omega t plus b cos omega t. Similar for momentum operator at a time t p of t also oscillating with the frequency. If you want, you can work out that separately. Okay. So energy in classical oscillator varies, but the energy eigenstate in quantum mechanics does not oscillate as we seen earlier. So a logical question arises that how can we construct a superposition of energy eigenstates that oscillate like a classical oscillator? So for that we want a wave packet that bounces back and forth without separating in shape. That means we want a coherent state. Coherent state means what? With the same wavelength, frequency, phase, etc. defined by the eigenvalue equation in terms of annihilation operator A. So the eigenvalue equation where ket lambda is the coherent state, then A ket lambda equal to lambda ket lambda, where lambda is generally a complex eigenvalue. The property of this coherent source are, first one is ket lambda equal to summation over n equal to 0 to infinity f of n ket n. Here ket lambda expressed as superposition of energy or n eigenstate f of n is expansion coefficient. Where mod f of n square equal to n bar raised to n divided by n factorial e raised to minus n bar, where n bar is the mean value of n. And the second property is the coherent state can be obtained by translating the oscillator ground state by some finite distance. If ket 0 is the ground state of the oscillator, then I can make a coherent source of superposition state using some translation operator. Okay. That is e raised to IPL by h cut ket 0 equal to 1 minus IPL by h cut plus 1 by 2 factorial minus IPL by h cut whole square ket 0. Okay. And this is expanded as e raised to x is equal to 1 plus x square by 2 factorial. So we will get it as ket 0 plus L by h cut root m omega h cut by 2 ket 1 plus etc. So the ground state changed to superposition state. It satisfies the minimum uncertainty relation at all times. That is, expression delta x square into expression delta p square is h cut square by 4. The next section we are discussing the Schrodinger's wave equation. So in this section we studied the time development of oscillator.